I'm Shilpa Bansal and I'll take you through the basic concepts of ratio and proportion in this video. Before we explore the mathematical definition, let us explore the use of ratio and proportion in real life. Ratio and proportion are used all the time in everyday life. The new HDTV viewing has an aspect ratio of 16:9. The concrete used for making building is made by mixing cement and sand in the ratio 1:2. To make a perfect cake, you have to ensure the ratio of flour to sugar is correct. You must have come across statements like weight gain is proportional to the amount of junk food eaten. The height of the tree is proportional to the height of the man in this picture. Did you know that the nature of beauty can be measured in terms of golden ratio? It appears many times in geometry, art, architecture, etc. Even in GoldenEye, James Bond 007 drove Aston Martin, which uses golden ratio in its design. In fact, modern day logos try to follow this rule to get aesthetically pleasing designs. The Parthenon in Greece and the Taj Mahal in India has golden ratio in them. So let's go to the mathematical definition of ratio. In mathematics, a ratio is a relationship between two numbers of same kind. It could be comparison of objects, persons, volume, marks, runs, or anything of same kind. It is usually expressed as x is to y, and it is written as x is to y or x upon y, which explicitly indicates how many times the first number contains the second. In layman's term, the ratio represents for every amount of one thing how much there is of another thing. So for example, if you have a statement which says Virat Kohli scored 60 runs and Gautam Gambhir scored 45 runs in the last one-day match. So what is the ratio or comparison? Ratio of runs scored by them. So that is 60:45, which can be reduced, right? Both are divisible by 15. 15 fours are, 15 threes are. So we have the ratio as 4:3. Let's take another example. We have a pancake. We have to make a pancake. The ratio of flour to milk is given as 3:2. Now, if you have 12 units of flour, how much milk is required to make a pancake? Now, this is a simple example of ratio, right? You have the ratio given as 3:2. So, if the flour is 12 units, which is 3 into 4, so obviously you will multiply the second one also with 4. So, 3:4 is to 2:4. So, you get the ratio as 12:8. So, for 12 units of flour, the required milk is 8 units. Another example, Ayush scored 104 marks out of 152 marks in sessional exam and 56 marks out of 76 in practical. So where did he score better marks? Right, so we straight away use ratio to compare. So Ayush's score in sessional marks is 104 upon 152, which is 52 upon 76. And in practical, he got 56 upon 76. So can we easily compare since the denominator is same? That is 56 is greater than 52, which means he scored better in practical exam. Now, the other method to compare would be percentage, right? We could have converted on a scale of 100. We would have known how much he has scored in sessional and how much he has scored in practical. But in this case, we will prefer to use ratio. It's easier to compare the basis in this case. So here we have used ratio to compare the marks obtained in sessional and practical. So let's just go through the properties of ratio. Ratio is a pure number. It has no units. Order is important. A is to B cannot be equal to B is to A. The second term of a ratio cannot be 0. Ratios are used to compare similar objects. Ratios are always expressed in the simplest form. Ratios can be used to compare more than two objects of similar kind. So you can have ratio of marks obtained as A is to B is to C. To express the value of a ratio as a percentage, we multiply the ratio by 100. For example, 2/5 ratio can be converted into percentage by multiplying with 100. So we get 40%. Similarly, 3/4 can be converted into percentage by multiplying with 100 and we get 75%. So can we say ratio is a special case where the denominator is 100. Let's take another example. If x by y is 3/4, find 5x minus 3y upon 7x plus 11y. Now in this case, can I say if I take x equal to 3k, y becomes 4k. So if I substitute these values in the question, I can get my answer. In fact, I don't need to substitute 3k. I can straight away take x as 3 and y as 4 because it will get cancelled. So straight away I have my answer as 5 into 3 minus 3 into 4 upon 7 into 3 plus 11 into 4. So 15 minus 12 upon 21 plus 44. You get 3 by 65. So that's your answer. Next question. Total income of Anya and Falak is in the ratio 4:5. Their total expenditure is in the ratio 3:4. Find the ratio of their savings if the expenditure is not equal to their salaries. Now, let us see if you're very clear with the concept of ratio. Many of my students simply just go over the ratio concept because they think it's very easy. Now, try solving this question and you'll be very clear whether you have understood the concept perfectly or not. Okay. So let me go slowly. So the total income is in the ratio 4:5. So can I say income of Anya is 4x and income of Falak is 5x? Similarly, I can say the expenditure is in the ratio 3:4, or can I say that expenditures are 3y and 4y? Now saving is income minus expenditure. So can we say SA by SF is equal to IA minus EA upon IF minus EF. So what do we get? 4x minus 3y upon 5x minus 4y. Now, can we have our answer? It's not possible, right? We don't know the values of x and y. So it's not possible to find the ratio of the salary. So the answer is data insufficient. We need more data to answer this question. Another way of solving this question would be, can I say 4:5 is the total income, or can I say Anya is earning 4/9 of total income and her expenditure is 3/7 parts of total expenditure. Similarly, Falak is earning 5/9 of total income and she is spending 4/7 of the total expenditure. Now you cannot assume income and expenditure to be one and try to solve. That would be wrong, right? Many students do this mistake. They take I as 1 and E as 1. They are not same and you cannot assume any value. It depends on income and total expenditure. So unless total income and total expenditure is given, we cannot answer this question. So here our answer would be cannot be determined or data is insufficient. Let's go through the laws of ratio. If we have A by B is equal to C by D, can I cross multiply and say A into D is equal to B into C? Can I rewrite this as D by C is equal to B by A, which is your invertendo law. Now your A into D is equal to B into C can also be rewritten as A by C is equal to B by D, which is your alternando law. Now in this equation A by B equal to C by D, if I add 1 on both the sides, I'm not changing the ratio or equation. So I have A plus B upon B is equal to C plus D upon D, which is componendo law. If I subtract 1 on both the sides, I have A minus B upon B is equal to C minus D upon D, which is your dividendo law. Dividing both componendo and dividendo law, we get A plus B upon A minus B is equal to C plus D upon C minus D. Now there's another formula on equal ratios. So if I have A by B equal to C by D equal to E by F is equal to K, then can I write A is equal to BK, C is equal to DK and E is equal to FK. So let us find the ratio of A plus C plus E upon B plus D plus F. That is sum of the numerator upon sum of the denominator. Now we have already seen A can be written as BK, C can be written as DK and E can be written as FK upon B plus D plus F. Can I take K common? So if I take K common, I have B plus D plus F inside the bracket, which gets cancelled with the denominator. So I get the ratio as K. So can we state that the sum of the numerator upon sum of the denominator, the ratio remains constant? Let's move on to proportion. When two ratios are equal, the four quantities composing them are said to be proportional. Equality of two ratios is called proportion. Mathematically, when A by B is equal to C by D, then A, B, C and D are in proportion, and it is written as A is to B is to C is to D, where A and D are called extremes and B and C are called means. So we have two triangles which are similar. The angles are same. It's just like one of the smaller triangle is magnified and made a bigger triangle, X, Y, Z, right? And the two triangles are similar. And again you can see the picture where the height of the tree is proportional to the height of the pole. Now what is the difference between ratio and proportion? Now we've already seen ratio is used to compare similar quantity, whereas proportion is used to compare dissimilar quantities. For example, ratio can be used to compare the marks obtained by student in BELCAT, but if we need to compare the score with the number of questions attempted, we would be using the concept of proportion. Like if we need to compare government apathy or anti-government sentiments with the popularity of Aam Aadmi Party or BJP, we need to use proportion. Let's see continued proportion. If A by B is equal to B by C, then A, B and C are said to be in continued proportion, and B is called the mean proportion or geometric mean of A and C. Let's take an example on proportion. Try solving this question. There are three travelers A, B and C who are about to eat a meal. A has 5 rotis, B has 3 rotis and C has none. They all plan to share food equally. C offers to pay A and B 8 coins for his share of food from A and B. He suggests that they distribute the coins in proportion to the amount of rotis contributed by them to him. So the question is, how many coins did A get? Okay, try solving this question on your own and then check with my answer. So let's just draw a table to understand the data better. So let's have the first column as the number of rotis initially with them. So A has 5, B has 3 and C has 0. So total number of rotis is 8. Now the pieces shared, can I say they are equally sharing the 8 rotis. So each of them had 8 by 3, 8 by 3 and 8 by 3. So what would be the contribution? See, remember the question is asking you that you have to find, you have to distribute the coins in proportion to the amount of rotis contributed and not by the amount of rotis consumed by them. Okay, so when A had 5 rotis and he had consumed 8 by 3, how much has he contributed? 5 minus 8 by 3, which is 15 minus 8, that is 7 by 3. Similarly, B had 3 rotis and he had consumed 8 by 3. So how much did B contribute to C? That would be 3 minus 8 by 3, or 3 3s are 9, 9 minus 8, 1 by 3. So now can I say the ratio of contribution is 7 by 3 is to 1 by 3, or that is 7 is to 1. So the ratio of contribution is 7 is to 1. So it's pretty clear that A will get 7 coins and B will get 1 coin out of the total coins of C. See, there is one more question, one more way of solving this question. If you're not very comfortable with fraction, you could have taken the number of rotis, that is, you could have distributed A's roti into 15 parts, that is, take a multiple of 3. So 5 into 3, 15. You could have, made A break his rotis into 15 pieces, and B's roti would be 3 into 3, that is 9 pieces. So total 15 plus 9, you would have had 24 pieces. So each of them would have had 8, 8, 8, right? So A has contributed 15 minus 8, 7, and B has contributed 9 minus 8, 1, right? That could have been another way of solving. Right, this question is totally based on the reasoning skill or the logical skills. There's hardly any mathematical formula used to solve this question. Okay, so let's just quickly go through all the formulas we have done in ratio and proportion. We have seen ratio is a tool which can be used for comparison. It compares one quantity of same kind with that of another. They can be expressed as percentage by multiplying by 100. Equality of two ratios is called proportion. Ratio is used to compare similar quantities. However, proportion is used to compare dissimilar quantities. When A by B is equal to B by C, then A, B and C are said to be in continued proportion. So that's all for today's class. Thanks for watching.